Hello everyone, my name is Tristi and today I am going to present my demo in front of you. My topic for today is Algebraic Expression, Class 8 Mathematics. So let's start. Before introducing what exactly is algebraic expression, let's solve one question which is based on algebraic thinking. So let's start. So now as you can see on the screen, there is a question related to algebraic thinking and we are going to solve mastic patterns. So have you ever seen mastic? Okay, so you might have burned a candle by using all these mastics, right? So let's start the topic by solving some of the questions related to mastic pattern. So if you have mastic, you can do it on your own, but I'm going to show you. You can follow me. So suppose let's start with a simple one. Suppose I'm going to tell you that you have to make L by using mastics. So how many mastics are required to make L? 1 L. So yeah, you are right. So there is 2 mastics. There are 2 mastics which is required to make 1 L. Okay. So if I make a table and if I write, so in the first column I'll write number of L and the second number of mastics required. Okay. So in the first term you will say, in the first figure, as you can see, there are 2 mastics. So number of L is 1 and how many mastics are required to make this L? 2. Okay. Now if I'll tell you to continue making L, okay, so now in the second figure what you will do, you will make 2L. Okay. So now this is 1L and now for making 2L you will add how many? 2 extra mastics. So now you have 2L and how many mastics you have added? 2 and 2 which you have added earlier. Okay. So now there are 4 total mastics. So there are 4 total mastics are required to make 2L. Now if you will do the same in the third figure, so if you will have 3L, so how many mastics will be required? So as you can see in this, there is a pattern. Okay, 2, 4, 6. Okay, you can say 4 if you have 4L, 1, 2, 3, 4, how many mastics are required? 1, 2, 3, 4, 5, 6, 7, 8. 8. So as you can see, if I'll ask you, can you tell me for making 15L, how many mastics? Yes, it's 30. Why? Because as you can see, 1 into 2 is 2. Now there is a 2 into 2 which is 4. Okay, and 3 into 2 6. So you can see the pattern. Okay, now you don't know. So number of so this is a variable. As you can see, this could be any number like 15L, 17L, 18L. So you don't know exactly how many number of L you would make, okay, by using how many mastics. So can I make some expressions like 2x? So for n number of like 2n, so for n number of terms you can have this formula. For example, if I'll ask you, like you have to tell me like how many L is required to make, how many mastics are required to make 30L, suppose 30L. So you will directly put it in that equation and you will tell me like 2 into 30 which is 60. So will tell me like 60 mastics is required to make 30L, right? So now as you can see, this 2 here, 2 into 1, 2 into 2, 2 into 30 and so on, 2 into x. So as you can see, this 2 is constant here which is not changing, but 1, 2, 30 and so on, it is changing. So we can name it as x. Okay. So now I'm going to show you what exactly is algebraic expression. Okay. So let's start. Yes. So what exactly is algebra expression? What exactly is algebra? So meet this girl. She is alien. She is saying hello. So hello kids, my name is XYZ. She is saying like hello kids, my name is XYZ on Pluto, PQST in Mars, and Plumy on Earth. I am so confused that I forget my real name. Now people call me a variable. Oh, can you guess why? Okay, so let's explore why people call it as a variable. Okay, now the idea of a variable. So the word variable means something that vary, change. The value of a variable is not fixed. So basically something that can vary, it means something that can change. As I have told you in my previous the question that we have done, like mastic pattern. So the 2 was constant, and the number of mass L was changing, so we can call it as x. So now you can see that the value of a variable is not fixed, it take different values. Okay, so now what are algebra expressions? So you might be wondering what are algebra expression. So let me introduce algebra expression by telling you a story, or asking you something to eat. Okay, so can you tell me, do you want some ice cream? Do you know what the flavor do you like the most? So there are a lot of flavors in the market right now, and these days remembering all the names of the flavor is really difficult. So suppose this is a girl, and she went to buy an ice cream in this shop, and she is really happy. And suppose she don't know what exactly the flavor, she don't know the name of the flavor. So the shopkeeper has shown her all the flavors. Okay, and she has to choose amongst any of them. Like there is a, let's say this is a blueberry flavor, this is a guava flavor, or a mango flavor, right? There are a lot of flavors, but she exactly don't know the name of the flavor. So can we name the flavors? Can we call it as a variable, because it is changing, and it is not fixed, it is changing, because we exactly don't know the name of the flavors. Okay, so now suppose you went to buy an ice cream, and ice cream the shopkeeper gave you a cone. The cone is always fixed, as you have seen in a shop, like cone is always fixed, but the scoops are different. So let's say this is a strawberry, this is vanilla, and this is guava flavor. Okay, now let's say I will give them some name. Like suppose this is a constant, this cone is a constant, it is not changing. So if you will buy any other flavor like mango flavor, or any other flavor like strawberry flavor, or I even don't know the name, so any flavor. So pineapple flavor, let's say, so chocolate flavor. So let's say I'm giving this name as 5. Okay, because this is a constant, as you know, 1 2 3 4 which have fixed value is constant. So let's say I'm giving the name of this cone as 5, value as 5, and suppose this flavor, I don't know exactly what the flavor it is, so I'm giving this the name x. Okay, it can take any values, so we can represent it as any alphabets, English alphabets, which is from A to Z. Okay, let's say I'm giving this name as x, and this is y, and this is z. Okay, so now if you will combine all the 3, now if you will multiply all the 4, like x y z, so this is 5 x y z. Now all the parts that we add together to form an expression is called term. So this is an expression, and 5xyz is a term. Okay, so now, so what are expressions? Any mathematical expressions which consist of numbers, variables, and operations are called algebra expressions. So as we have seen in the previous slide, like there is an ice cream which is 5xyz. So this is a term, and this is also an algebraic expressions where we have multiplied 5 into x into y into z. And now, so in this expression, so in this term, so there are 4 parts. As you can see, there are 4 parts, 5xyz. Now let's say, so this is 5 x, y and z. Okay, now there are 4 parts, as you can see. So now these all the 4 these 4 parts are called factors, right? So x, y, z and 5 is a factor of this term. So 5xyz is a 5xyz is a term, and here 5x, y, z are the factors of this term. Okay, now if these are the factors, then we can call it as an expression, right? So all the factors multiplying together and making an expression. So basically, suppose now you have learned about factors and algebraic expressions. So tell me, so basically suppose suppose your ice cream fell from your hand, and suppose you were eating an ice cream and it fell from your hand. Okay, so you went to that shopkeeper, and you asked him or her to give another scoop of ice cream. Okay, so now the shopkeeper gave you an ice cream, but it has only 2 scoops. Okay, now suppose this is an ice cream. There were 3 scoops, like 5 x, y, z, having different flavors. But now the ice creams that he has given you had only 2 scoops. Okay, this is x, y and 3, suppose 3. So now you got very angry because you had 3 scoops and now you have only 2 scoops. So you might be thinking that this is unlike. Okay, so these two expressions, like these 2 terms, are unlike terms. Okay, so one is unlike terms and another is like terms. Okay, so as you can see, in these factors, the factors that we have discussed earlier, there are 2 types of factors. One was what? Algebraic factors. These are algebraic factors. Okay, and this is an numerical factor. Okay, this is a numerical factor. And if to make any equation a like term or an unlike term, okay, so the algebraic factors should be same. So as you can see in this example, numerical factor might be different, it doesn't matter, but algebraic factors should be same to make an expression a like term, right? So basically in this example, you have seen that this is not like term, and suppose the ice cream shopkeeper gave you the exact same scoop. Okay, same ice cream, like you had 3 scoops on your ice cream. Now he has given you 3 scoops. So now you have got satisfied, like okay, this is exactly the same. So suppose you had 5 xyz earlier, and now you have 3 xyz. Okay, now 5 xyz and 3 xyz. So can you tell me, these are like terms or unlike terms? Yes, both are like terms. So this is numerical factor, it doesn't matter, it can be changed, but xyz, these are algebraic factors, it should be the same. Okay, so what are expressions? Any mathematical expressions which consist of numbers, we have discussed earlier. So terms, we have also discussed about terms. So in the ice cream example, you have seen the ice cream has 3 scoops, which is 5 xyz. Now this is a term. Okay, now suppose you are really hungry and you wanted to eat some more ice cream. Now say you have bought one more ice cream which has only 2 scoops, let's say 3xy. Now you have 5xyz earlier and now you have 3xy. Okay, So these are two terms. Okay, there are two terms because you have two different ice creams. So if you have only 5xyz, this one, so it is called monomial. Okay, because you have only one term. 5xyz is only one term. But if you have two ice creams, so it has two terms, which is called binomial, right? And if you are more hungry, then you can buy a new another ice cream having n number of scoops. Okay, so suppose, let's say you have 3xyz. So now you have three terms, so it could be trinomial. And suppose you have many terms, so it could be polynomials. So now I guess you have understood all the concept of algebraic expressions. So yes, thank you so much, and keep studying. Enjoy.